Introduction to Coding Success for All, through Robotics and Logo for Grades 3 to 8. My name is Lisa, of Neufeld Learning Systems Incorporated. Coding, a marketable skill for the 21st century, provides limitless, creative opportunities for all students, teachers, and parents, now and into the future. This introductory, hands-on workshop uses videos and selected examples to introduce codes that give clear visual results which encourage all students, including those with individualized education programs, IEPs, to take risks and to learn from mistakes. It introduces Logo, a simple, powerful mathematical language known as the language of learning. Free access to Logo on any device encourages all students to explore with confidence to achieve success. This video is made up of 3 parts. Part 1 is 5 minutes, Coding Introduction. Part 2 is 8 minutes, Coding on the Computer Screen. Part 3 is 10 minutes, Coding Activities for All, in your ebook. We suggest that you use this video for yourself, for your class of students, teachers, or parents. We suggest that you use this video in one of the following ways, using 2 computers. Suggestion number 1. Initially, put computer number 1 aside and watch the entire video of all 3 parts for an overview on computer number 2. Suggestion number 2. Or, on computer number 2, see the video to the end of part 2, or to the end of part 3. Then, in order to make Logo accessible on computer number 1, click on weblogo.terrapinlogo.com. On the screen of computer number 1, you will be asked for a classroom name password. You will be given the password by contacting us at www.umathx.com/contact-us, or by an instructor in a class. Then follow the steps in video part 2 and video part 3 on computer number 1 with Logo. We now begin part 1, followed by part 2 and part 3.
The title of this session by Rudy Neufeld is Introduction to Coding Through Robotics and Logo with a Math Focus, a hands-on workshop with follow-up opportunities. This session models a learning environment which encourages one to learn by coding or teaching a robot. We capture interest through an interactive video to introduce code and corresponding action. Then we encourage further exploration through hands-on activities by giving participants free access to an ebook of activities and the Logo computing code to control a robot on their own computer screen during or after the workshop. A session testimonial after an NCTM conference states, "This session is an intuitive, simple, yet powerful introduction through lessons to vital coding skills and personal access to a programmable robot on a computer screen. Great activities in an ebook present hands-on opportunities to enrich STEM with a math focus." The material in this workshop is taken from the Introduction to Coding ebook, which can be accessed by participants at www.umathx.com under Coding. We will refer to specific pages in this ebook. You can access pages in the ebook now or later for specific activities in your own time. Here is the table of contents. As an introduction to this workshop, we list a number of helpful comments from the foreword and the preface of the ebook. Coding creates a learning path and gives the learner direct participation in and responsibility for his or her own learning. Manipulatives help to move the learner along the pathway from concrete to abstract. This is critical in the learning of and understanding of mathematics. Robots engage the minds of students, teachers, and parents in rich, exploratory, open-ended inquiries, thereby creating communities of innovation as they work together and share explorations and findings. Teachers and parents make learning possible for all students by establishing an environment of risk-taking. In the flow of our learning, in chapters 1, 2, and 3, we begin with self-movement for the person robot, followed by activities with a mechanical robot, a bluebot. Finally, we present activities to code a robot on the computer screen. In step 1, a person walks the code. In step 2, the coding is done using bluebot keys on the bluebot. Later in step 2, the bluebot is coded using a computer keyboard. And in step 3, the robot moves to the computer screen and becomes a turtle. It is now coded with keys on the computer keyboard or tablet. Step 1. The first steps to coding. On top of page 17, a person walks the code. Then in step 2, we work with a robot, the bluebot, on the floor. Code a floor robot, the bluebot. The prediction activity chart on page 29 is to be used with an investigation activity. The user would predict, record, and test at each line. For example, in line 3, one should predict, clear, move 1 unit back. The bluebot brings science, technology, engineering, and mathematics into the classroom and builds foundational skills for lifelong learning. One can move the bluebot forward, backward, turn left and turn right, and teach sequencing, directionality, problem solving, counting, and estimation. Now we make the jump to step 3. Chapter 3. Coding logo on the computer. The title of this session by Rudy Neufeld is Coding Introduction with a Math Focus Through Robotics and Logo, a virtual, hands-on activity with follow-up opportunities. Coding through robotics models teaching with understanding. Coding has become a vital skill for the 21st century. It gives learners direct participation in and responsibility for their own learning. The computer language logo models a learning environment which encourages one to teach rather than simply to tell. Logo is an intuitive, simple, yet powerful visual coding language designed especially for young learners. Dr. Seymour Papert of MIT developed this powerful coding language, which uses code to direct a robot on the floor or on the computer screen. I met Dr. Papert at MIT. The meeting determined my future direction in education. Logo is a model for learning. One learns from mistakes. In these examples, we are learning by teaching a robot. In the first example, from 1990, working in a classroom. And in 2020, we are working with the bluebot robot. Logo is referred to as the language of learning. The robot speaks mathematics, and through the use of challenges, participants will discover how mathematics can build structure and design. In this virtual session, we will give access to coding and robotics to capture the interest of participants in interacting with mathematical concepts using video and exploring further hands-on activities. We will give participants free access to a robot on your computer screen, as well as guided activities for you to follow along, if you wish, during this session, as well as after. For free, complete functionality to the Terrapin Logo learning environment on your own computer, enter the address shown here in your browser. The following will appear. Click on the second graphic. Then enter the classroom name that you will be given for this session. Two panels will appear. The graphics panel has a robot at the center, and the listener panel is where we write code to command the robot. The following examples will demonstrate the Logo learning environment. I will start the first example by using some simple commands. First, in the listener panel, I'll enter home, clear screen, set width 3. This sets the width of the path that the turtle takes so you can see clearly. I'll use a slow turtle, and I'll set the pen color to 4, which corresponds to red. When I hit enter, all of these commands are executed at once, but you'll only see the final command, set pen color, because the turtle hasn't moved yet. So let's write another set of commands. We'll start at the home position, clear screen, and now let's move forward 67 and turn right 90 degrees and back 67. I enter that, and now the turtle has moved, so we've got a code that gives us action. Now let's clear the screen, and I want to chunk the next set of commands, which is a process where I can break a line into parts and see what's happening one step at a time, which is a good tool for problem solving. So let's go forward 67 and hit enter. Then let's turn right 90 and enter. And let's go back 67. Let's clear the screen, and let's clear the text as well for clarity. Now I'd like to repeat 4 times, square brackets, go forward 60, turn right 90, and pressing enter, we get a square, which is what we would expect. Let's add a bit more to this. So we'll repeat 4 times, square brackets, and let's repeat again, and do a forward 60, right 90, and then at the end of the second repeat, we'll add a turn right 90. I would discuss this with my partner or group and come up with a prediction of what we think will happen here. Hitting enter, let's see what we get. And there are many more commands we could use, but this gives you an idea of the learning. I'm going to clear the screen, and let's go home, and let's clear the text as well. Building on the previous line, let's add a forward 60 and see what happens. And if this wasn't what we wanted, we can learn from our mistake by adapting our commands. In Logo, we build progress on progress. We build knowledge on knowledge. So suppose I want to teach a lesson. Let's call it box. I type 2 box and enter that, and we get this editor screen. The 2 tells me a lesson is coming, and I'm going to teach it to create a box. It's repeat 4 times, go forward 60, and right 90. Now if I click the Run button, we get the message, box defined. So it's like you go to school and learn a lesson based on certain concepts, and then the next day you build on what you already know. So I built a lesson box based on commands that I had learned previously, and now box becomes a new command, a new concept that I know. As a teacher, I would test that concept, so let's enter box and see if we get what we thought we would get. Really, we're seeing whether we have taught it correctly. Are we going to get what we expect? So we hit enter and we get this shape. Now let's try repeat 4, and we can be more efficient now. Let's make a box and then turn right 90 and enter that. So we have taught a new lesson based on present knowledge, as you do in school. We have taught the turtle to make a box. Then we tested that lesson to see if you, the teacher, have taught it correctly. Use the new lesson to build knowledge on knowledge. We could now make another lesson that draws multiple boxes in new ways, and build upon that as well. This is a simple example, but it gives you an idea of what is possible here. And you can see that it showed. Coding through robotics models teaching with understanding. Introduction to Coding through Robotics and Logo with a Math Focus. Video 3. The following appeared in a 2021 Turtle Talk newsletter by Terrapin, creators of Logo. New curriculum from Neufeld Learning Systems brings a fresh perspective to coding with Terrapin Logo and Bluebot. Introduction to Coding through Robotics and Logo leads students into an amazing world rich in math concepts. Each chapter offers objectives and a plethora of fun activities to achieve them. Here in Video 3, we will work with a few of these activities referred to in the Turtle Talk newsletter. You and your group or class may want to log in to Logo on your computer. Recall that you were given the login and password in Video 2. Please see the ebook, page 61, Activity 1, Investigate, Predict, Journal. We could now use the turtle in Logo on your computer to help in investigating. For example, in the second line, predict the path you think will be created and record this on paper. Now pause this video for a few moments and command the turtle with Logo on your computer. Discuss your prediction along with the computer result. Now study the red design at the bottom of the ebook, page 77. Predict. Discuss a set of code that would result in this design. Test your prediction with Logo on your computer. Now pause the video briefly to discuss your prediction. Discuss and test on your computer the 2 lines of code highlighted on page 77 of the ebook. And we get 24 multiplied by 15 equals 360. Now in another example, see ebook page 88. To help in understanding how angles affect design, please work through the following with a partner and record a summary in your journal. In the diagram to the left, each of the 4 sweeps in the exterior angles shows the action of a turn that the turtle makes on the screen. First, think through the design. Then, chunk and test one line at a time to match a light-colored design. Command each of the lines, one line at a time on your computer or tablet, to make sure that you understand functions of lines of like color. Now use the highlighted code on page 88 to help you in predicting code for these shapes. Test the code with Logo on your computer. From these diagrams, in a square, 4 exterior turns are all the same, they add up to a circle. Hence, they add up to 360 degrees. The code for designing a square is repeat 4, forward 50, right 90. We will now explore the exciting potential of the computer language logo in building new learning on existing knowledge. We investigate the following concepts in the ebook. In Chapter 5, we will simplify our work by teaching the turtle a new lesson called a procedure, based on a previous command. Note the graphics at the top of page 122. The turtle is taught lessons. It goes to school. We will give an overview in the examples that follow. We suggest that you and your group use the ebook for more steps to help in discussions leading to understanding. To this point, you communicated with the robot, the turtle, on the computer or tablet screen through a code called logo. Understand that a procedure is a set of commands used to perform a particular task. We will build lessons and lessons on lessons. Here we will teach a lesson, square, within logo on your computer. If you need help, recall the process by checking in video 2. Key in 2 square in the listener window and 2 square appears in the editor window. Then use square to teach lines of squares. Try this yourself or with a group. Key in 2 square in the listener window. The editor window will appear. Complete the commands for square. Then click Run and square is defined. Then remember to test the lesson. Key in square and adjust it by adding slow turtle within square. Now teach lines of squares using square by keying in 2 lines of squares in the listener window. You will be asked to overwrite. Simply continue. Then, within lines of squares, add repeat 4, square right turn 90, forward 60, left turn 90. Test the lesson lines of squares by entering lines of squares in the listener window. Make additional changes, press Run, and test again. Review and discuss the process. Now we will introduce variables in lessons or procedures. In this chapter, we will learn how to code using a powerful tool, a placeholder or variable. Now we will show our task. Teach Chinese nested boxes with one variable. See page 157 and 161 in the ebook. On page 161, the procedure box L is shown. Teach and test the procedure box L, page 161. When the value of L is 30, simply enter box 30 to substitute 30 for L. Remember that a colon before a letter or set of letters indicates that it is a variable. Please pause the video while you teach, test, and adapt using variables. In Chapter 7, we introduce recursion. See pages 182 and 183 in the ebook, and work through Activity 1 and Ideas 1 and 2. See page 196 to get ideas for stopping a runaway turtle. Now we will open doors to the Logo learning environment in the XY plane. See the ebook pages 202 and 207, work through Concept 1 on page 202, and then read through Concept 4 on page 207 and test Set XY and Set Pause at the bottom of the page. Finally, we will introduce multiple turtles. In this section on projects with multiple turtles, we will establish a process for new learning. In most cases, you will not be told exactly what to do. We would like you and your group to first explore, then do your best to describe the function of given code. Then predict, test, explain, and follow up. Use the ebook page 237 and logo on your computer to explore the function CTurtles20, tell all, to result in groups of interacting turtles like you see here. Investigate by experimenting and challenging groups in a class. We hope you have enjoyed these videos. Thank you for watching.